Yes. Yes. So last time we were trying to understand the three different types of machine learning: supervised, unsupervised, and reinforcement. Right. So as we've seen, supervised is basically with the help of teacher, mentor, and here we use training data set. In unsupervised learning, we basically give them some sort of event decision type of pairs, and the program will basically keep on working by itself rather than having any manual effort overlay or any trained data set to help it out externally. Then we have a reinforcement learning where we set up a mechanism where the machine starts learning by itself. Okay, this is again a kind of new or latest advancement towards it, and we'll see how we achieve that thing. Okay. Does anybody have any confusion? Have you looked at the video which I shared with you?
Yeah, I had a look at them.
Okay, great. So I think we have a fair idea. Whenever you do hands-on programming, then we'll basically try to see how we basically differentiate our programs, how we differentiate our work into these categories, or how to basically go for a specific category in terms of supervised or unsupervised. So if somebody mention it, we are trying for unsupervised, why and how, and based on the solution, we can categorize the programs or solution based on the approach suggested throughout the group or the team. Okay, so that's why this differentiation is really important to learn. Uh, Again, to revise, supervised machine learning is defined by its use of labeled data set to train algorithm that to classify data or predict outcomes accurately. Okay, so here we are talking about some already classified trained data set which basically predicts outcome accurately. So there are quite a defined path in terms of supervised learning, right? As we've shown the image of a student or a infant learning in the school. Okay, might be first standard, second standard, at that level. The input data is fed into the model. It adjusts the weights until the model has been fitted appropriately. This occurs as a part of cross-validation process to ensure that the model avoids overfitting or underfitting. Okay. Then supervised learning helps organization to solve variety of real-world problem at a scale, such as classifying a spam filter in a separate folder from your inbox. Some methods used in supervised learning include neural networks, naive Bayes, linear regression, logistic regression, random forest, so on and so forth. We'll learn few of them. Please don't worry. But yes, we need to understand in terms of the differences between these three, and we're going to understand right now. And basically, we'll be trying to go deep into these things, and then we'll start working on various, other tactics so that our solution will be complete in itself, and then we'll move on to the various libraries available within Python to make sure our solution is in line with those thought process we just learned in terms of machine learning or unsupervised learning, supervised learning, and so on and so forth. Okay, to stress more supervised learning, consider yourself a student sitting in a math class where your teacher is supervising you on how you're solving the problem or whether you're doing correctly or not. The situation is similar to what is supervised learning algorithm. The input provided as a labeled data set. A model can learn from it, or it basically gets referred every time there's a separate decision to be followed, taken. Labeled data set means for each data set given an answer or a solution to it is given as well. Each decision and the alternative options, like we mentioned in the decision tree. This would help the model in learning and hence providing the result of a problem easily. I believe we have gone through this slide last time. Anybody have any questions up till now?
No, I'm good.
Okay, great. Simple enough, right?
Yeah.
In terms of flow chart or how we achieve these things, there's an input raw data, You can think it from our spam email examples. There's a raw data, there's a training data set or desired output filter I had there, and then I have an algorithm are nothing but some rules I have fixed to filter these emails, right? So some of them might say, as you have suggested, informal words in a subject line or in a content. So that means the mail is not business email. I can clearly categorize the mail into spam or into informal or something like that sort. Or there are typical few words like phishing attacks. You are going to receive an award of $10 billion or something like that sort. Now these are spam, right? Unless and until you applied for that award, you won't receive any award, right? Nobody's there sitting on the bank to throw $10 billion to you, right? So these are the realistic training data set or desired output I already programmed in my program. So there could be a reference data set, data frames, where I normally refer to whenever I categorize my input raw data, and then I do a processing in that in terms of categorizing this email, as we have referred to that example, into different folders, inbox, informal, and all those folders, whatever you have decided. So that's a kind of achieving the solution. And at the output level, I have all these categorized emails, right? So this is how the supervised learning works in a typical example. You should be able to explain it by yourself. Pardon me, I believe I have not shared the presentation with you. I'll share just after this session, and you can take it up from there. Pardon me for that. I think I forgot that. Okay, then unsupervised learning.
Just one thing, Ravindra. Okay,
Sure, sure.
if you go to the previous slide, right? Okay, here input. Sorry, the slide 90. The raw data is there, and you have an algorithm, and output is there. And again, no, the supervisor training data and desired output. That part we are good. Okay, but by any chance, why we are showing algorithm and processing separately? Actually, they are one and the same, right? Algorithm is what which is going to process it, right?
No. Okay, logically thinking, see, if you think as an execution wise, this can be same or different, right? But when you say there's an algorithm, so there are a set of rules I built, right? Set of rules, like I have a training data set where I referred. Let's take in a spam filter type of solutions I'm building. So what I'm building here, I'm trying to formulate a rule. If there's a word called HEYA, HEYA, that's an informal word. HEYA basically speaks about an encouraging thing to you. Normally, business people don't use HEYA. They normally use congratulations, or they don't even use congrats. Means, well, there are particular well, this again depends on regional culture and all those things. So I'm just basically thinking loud here. So there are some examples where I can categorize the mail based on the subject line, based on the content. So I tell my program, hey program, if there's a mail with Aya or buddy, or uh, um, get out of here, means this is a phrase normally used in eastern part of North America, like New York, Connecticut, and all, where it doesn't mean anything. It means, okay, yeah, I understood you. Let's not talk on this thing, or let's stop. Wasting our breaths on talking on these rubbish things, something like that. So, well, this depends on culture. This depends on the group you are working with. So there are some informal word rules I have made, and that's my algorithm. Now, the training data set basically even keep track of further such words which are not categorized. And it normally compares with these rules, saying, is it part of my algorithm? If yes, then no problem. And if it's not there, then I might need to raise something, or I might need to warn somebody. So there's a level of clearly categorization, and there's a level of improvement going for the further process, further categorization in a spam email type of scenario. So we need a training data set. We need an algorithm where I have the rules, and then I have certain preconceptions of desired output. And these three make my program, my solution, categorize these raw input data after processing to categorize into 3 different outputs. Okay. What other example can we, could you think of so that I can explain you in a better
Yeah,
scenario?
yeah, I'm getting what you're trying to say, Ravi. Okay, algorithm is set of rules, right? Okay, and then right, you test it using the training data set. You say that if I give this input, what should be the output, right? So that is what is the top picture. That part also I'm getting it. Okay, but I don't know. The one thing that I'm having difficulty is that no, see, this processing is shown separately, right? Okay, so is the processing different from the algorithm actually?
Here, algorithm is a set of rules.
Uh-huh, uh-huh, uh-huh.
Why we need algorithm?
Mhm.
In terms of computer is a dumb person,
Correct.
I'll not call it personality. It's a dumb thing. It couldn't understand, anything except binary. We make him understand addition, calculation, or addition and multiplication, nothing else. Now we devised a rule set where the computer can do subtraction as well as divisions. Now we have achieved with certain set of rules, certain programs, right? And these programs or these way of working or set of rules are algorithms. Does that make sense, or am I confusing you?
No worries, Ravinda. Yeah, sure.
Okay,
I'm
let's put on for a couple of slides. Okay, and if you couldn't get what you can say confident on classification of these things, we'll revisit. Don't worry. Okay, there are quite a good number of
sure,
videos also I've
sure,
already
sure,
shown.
sure.
But yeah, let's wait for a couple of slides, and we'll revisit this slide again. Don't worry. Okay. Now unsupervised learning, where I'm stepping into a next step where rather than building those rules by myself, what I do, I build, I use somebody else's rules, which are already defined because, I'm in an emotionally board, right? So other humans also working on these things. So I copy, paste their rules, try to include in my solution, saying, hey, boss, this is the, data set you're going to use for algorithm. And then what I do, I tell them if there's any exceptions, do let me know. Or if there any exceptions, do use these others, try with these other set of things. But don't come back to me saying there's an exception. So there's no warning to the listeners, warning to the programmer. In a sense, it will not stop working if there's an exceptions. So we are continuously make the program work, evolve with the trained data sets which are already clamped or added, rather than looking back to the supervisor every time. Let's try to understand. Unsupervised learning, also known as unsupervised machine learning, uses machine learning algorithm to analyze and cluster unlabeled data set. Now, unlabeled data sets are basically we are talking about some already defined rules as well as already defined or categorized data sets which will come at play in unsupervised learning. These algorithms discover hidden patterns or data grouping without the need of a human intervention. So here I'm not planning to have any supervisor as such. Only there's a reference material. Only there's a reference data set where I go and try to match the learnings with those data sets. Its ability to discover similarities and differences in information make it ideal solution for exploratory data analysis, cross-selling strategies, customer segmentation, image and pattern recognition. Now here what trying to do, I'm trying to refer to an algorithms or algorithms in normal scenario where I try to categorize the solution or try to decide on the event and the path to be chosen within a given decision tree, within the gambit of solutions, rather than referring to anybody extra or referring to anybody external to the solution. It can be an external, programmer, or it can be external algorithm, which is I might need to refer to in case of exception, but I have internal alternative paths already developed within my solution. It is also used to reduce the number of features in a model through the process of dimensionality reduction. So I'm trying to have a limited sense of accessibility for the external thing So the efficiency built in, because the solution based on real permutation combinations, it's efficient, it's progressive in nature. Okay. Now this is what I call principal component analysis. So I have all the components like the algorithms, the set of rules already been into my solutions, and singular value decomposition. So I go progressively achieving these alternatives based on the set of rules or set of algorithms I already included in my solution. And these basically two different approaches, principal component analysis and singular value decompositions. We'll learn on it whenever we do hands-on programming. So don't worry on that part. But right now, in unsupervised learning, we have these two alternatives, two type of unsupervised learning called PCA and SVD. They are normally referred as a principal component analysis and singular value decomposition. Other algorithms used in unsupervised learning include neural networks, clusterings, or k-means, and so on and so forth. So we're going to have a look at these also. So we're going to do some hands-on programming on these also. So here the changes is basically I have an input raw data, unknown output, no training set. I don't have any training set as such, but I just have the rules. Pardon me. I just have rules to basically filter the data. So I have fitted with certain kind of filters or certain kind of categorization mechanism by within the program itself. And there's no trained data set or there's no supervisor attached within the solution. So there's no external dependency as such. And then I'll get the output within the gambit of solutions. So this is also something sometimes called self-organized learning or without pre-existing labels. As you saw, the supervised learning, the data set is properly labeled, meaning set of data provided to train the algorithm. The major difference between supervised and unsupervised learning is that there is no complete and clean labeled data set in unsupervised learning. Unsupervised learning is a type of self-organized learning that helps find previously unknown patterns in the data, in the data set without pre-existing labels. Does that make any sense? Or am I confusing more? I know this is a bit of, quite longer topic.
I understand, yeah.
Okay, sure. So it's again, even if you don't, whenever we do hands-on programming, you'll get all your doubts clear. So please, don't worry right now. These are I have clearly mentioned or repeated for our interview purpose. So you can refer to these slides whenever interviewer asks this question. These are actually technical in nature. These are basically, good amount of activity diagram or flow chart in terms of understanding the execution of these supervised or unsupervised learning. Let's try to understand from a different point of view. Criteria method-wise input and output variables are given in supervised learning. In unsupervised learning, only the input data is given. Okay, so we are trying to progress on a decision tree based on certain algorithm. That's all in unsupervised learning. In supervised learning, I normally have a pattern to refer to. Analysis of data mostly uses offline analysis. So most of the time, the solutions can come back to the supervisor and ask which data set is more suitable for this type of input data and all those things. But in case of unsupervised learning, we use real-time data analysis or real-time data comparison with the set of algorithm already included in the solutions. The goal in supervised learning, we have output is predicted using the labeled input data set. And in unsupervised learning, the output is predicted based on the patterns in the input data set or based on the algorithms we are using as far as unsupervised learning goes. Okay, let me play a video for you and you'll understand, how this supervised or unsupervised learning is basically differentiated at a. Wait a minute. Okay, it's a small video. Let me, share that with you here. And I'll share a link with Eric also, so that you'll get a 2-3 trainers approach. And again, whatever fits your thought process, you can use those approach in terms of categorizing these different supervised, unsupervised, and reinforcement learning. Let's have a look at it. Could you see the video? Could you able to see the video? Yeah. We got an idea of a problem type and a solution, right? So here we have supervised learning for regression as well as classification, a model data to verify with or to compare with, a pattern matching. In unsupervised learning, association and clusterings are mostly used with the continuous data flow to analyze with association and categorization. In reinforcement learning, we have the machine is learning based on event and scenario, and it keeps building its overall the trained data set by itself, and keep learning with leaps and bounds. And we have a award or penalty kind of programs to make sure whenever we achieve certain results, we award with whenever there's we skip the iteration, we normally penalize, and so on and so forth. We'll learn how we do this thing in a programming diagram in a few slide. No, not in a few slide. In our next or next to next session, and then we'll clearly understand how to differentiate between these three elements. Right now, just try to relate the problem with the categorizations. If you are not very sure about the categorization of the supervised, unsupervised, or reinforcement learning, well, reinforcement itself is a kind of continuous evolution process. But in terms of supervised learning, we have a fixed data set or a result set to compare to, or a pattern to compare to. In terms of unsupervised learning, we have to refer to a few number of associations or clustering to make sure whatever we are achieving is in the as in the selected option within along the distribution. Okay, we'll have a look at it in in some time. Let's try to continue. Do you have any question for me as of now?
No, sir. Yeah.
I'm good.
Okay, great, no problem. Then there are certain solutions we use based on both world. Here we are talking about supervised and unsupervised learning mixing together, where I keep updating my label data and including in the solution, so that whenever I run the next iteration of the categorizations or the learning, I'll have the trained set of rules to make sure whatever I want to achieve is achieved to the successful level, or achieved at a accuracy better accuracy levels. Semi-supervised learning offers a happy medium between supervised and unsupervised learning. During training, it uses smaller label data set to guide the classification feature extraction from a larger unlabeled data set. Semi-supervised learning can solve the problem of having not enough labeled data, or not being able to afford to label enough data to train supervised learning algorithm. Nowadays, whenever we try to achieve something new, we normally use a semi-supervised learning, and we'll see how and why, because these are kind of best of both worlds. So we have certain already developed solution, already developed data sets available, trained data set available, and then I want to achieve something new on top of that, whatever we have achieved together within the open system community or within the scientific group I'm working closely with. So it's a kind of based off both worlds. Okay. Then there's a reinforcement learning. Reinforcement machine learning is a behavioral machine learning model that is similar to supervised learning, but the algorithm isn't trained using sample data. This model learns as it goes by using trial and error method. So I just have one data set to refer to in terms of taking decision based on the event. As simple as that. If you want to talk about reinforcement learning, I normally give an example of dot robot of Boston Dynamics, where I have certain event already programmed, so that if there's a snow, how to walk on the snow. If there's a water, how to walk through the water, or how to ignore water. If it's a mud, how to ignore mud, how to walk on steps, how to turn left, right. These are the events I have already programmed. But in case of any exception, we'll try to use the mix and match of the whole thing. So it's kind of mm, trying to achieve, reinforcement learning where we have certain data set to refer to. But in addition to that, I also can generate exception in any new such events occurred to the given executions. This model learns as it goes by using trial and error. A sequence of successful outcome will be reinforced to develop the best recommendation or policy for a given problem. IBM Watson is another good example. That one, Jeopardy, which basically, that won the chess championship and blah, blah things. So it's really good example. The system uses reinforcement learning to decide whether to attempt an answer or a question, as it were, which square to selection on the board, or how much to wager, or especially on daily downs. So daily double. So what I'm trying to do, this is basically referring to the chess match, which the IBM Watson had played against, I believe, that Russian chess player, right? I forgot the name. So, those kind of scenarios. So they're trying to basically guide you how to have a reinforcement learning added to the computer, where I have just event and executions along the decision path, along the decision tree. And then it choose from there. If there's a third path, then it might be basically a new learning for it, and it will get added to the database. So here I'm continuously improving my learning, and that's why it's called continuously improvement learning by itself, reinforcement learning. Again, this is a futuristic approach. Still, there are not so many solutions available in reinforcement learning, but we want to reach there sometimes. And this is a very time-consuming phenomena. To build IBM Watson, they took almost 25, 26 years to build those data set and to make sure it started learning on its own and input the data set or train the data set to the Watson, or fed it to the Watson, to make sure the Watson by itself knows all the permutation and combinations, which even that, Gary Kasparov, I believe that's the name of that chess player, already used, and few others as well. Okay, like there was some Indian chess champion at that time, Mr. Anand, if I'm not wrong, and he also had his own theories and decision tree already implemented in playing chess, and that's how we achieved that chess played by a supercomputer. IBM Watson was a supercomputer. It's like multi-processor, multi-storage, and blah blah blah. Okay, so this case study is available on IBM's site. I'll share the link with you as well. Now in reinforcement learning, what I'm doing, it's like input, process, output. So in process, I have a kind of algorithms. I have a a kind of fixed set of rules which are getting improved or added by itself. There's an agent where I try to attach a process finalizations where I have a disciplined states of events versus decisions already feed into the reinforcement learning solution. And there's a reward and penalty based on the execution outcome. Reinforcement learning is a type of learning that based on an interaction with the environment. It is rapidly growing, along with the producing a huge variety of learning algorithms that can be used for various machine learning applications. So here I'm talking about various different applications or various different solutions where we try to enforce reinforcement learning so that there be the least minimum efforts required by either programmer, solution givers, or anybody else which is external to it. Okay, we use a reinforcement learning even in our those unmanned aircraft and all those things. To begin with, there's always a start and end state for an agent or an AI-driven system, so that there are fixed number of events and the response already given to the reinforcement learning solution bar diagram, where it chooses from the already pre-programmed event plus response type of mechanism. But if there's an exception, then also it has certain thing to refer to or certain thing to go to, so that in those scenario, either it's basically added those events to the program or to the database, so that next time if that event occurs, it can take a decision on its own. The scenario is wherein reinforcement learning is able to find a solution for a problem. The example of reinforcement learning includes self-navigating vacuum cleaners, say driverless cars, scheduling of elevators, and various dot robot, Atlas robot, and various other self-driving IOTA or Internet of Things of mechanism. Okay. Now I believe I've spent enough time in categorizing these three learnings. This is more of a theoretical to approach to, but this is necessary for our interviewing process. Okay. Now let's go on to the actual getting our hands dirty kind of scenario. We'll just revisit this file and CSV processing in Python with using some libraries, so that we know how to generate actual data scientist solutions. Okay, so let's try to revisit. I believe we had gone through this CBS, right? We had done this CBS file read, right? Could you recall those things? Anybody? Are you there?
I think we did file input output. I'm not
Right.
sure.
Some CBS comma separated values, right? We'll just revise those things, don't worry. Now we are actually building some solutions in terms of data scientist solutions, right? So let's try to understand. This is a kind of repetition, but yes, it's good, thing to revise, no worries. CBS stands for comma separated values. It was the oldest and the simplest form of storing data in a tabular format. So you have flight files mostly, where you have a comma separated data set as shown in the picture. I have a salary with years of experience and relative salary. So for 1.1 years of experience, 39K something is the salary. And then for 1.3, so on and so forth. And I go on basically having these details. So the HR person can refer to this database. It's a plain flat file. So it will not basically eat up too much of your space. Even on network, it is freely or it can be transferred with the maximum 99% of compressions, right? So the data serve will be the most efficient. That's why we use CBS files. It is important to know how to work with CBS because it most rely on CBS data in our day-to-day lives as a data scientist. So whenever you have a data to be processed within your network, you're not accessing anything outside your network or outside your physical computer, you try to use CBS where security is not is not a threat at all. Or if you're working at your home and you're trying to play around with your phone's address books or something like that, which are normally in a CBS format. Even if you're using Apple phone, the Apple phone can extract its calendar as well as contacts in a CBS file format, so that you can use it within your Python gambit and try to get the backup or try to convert this data to Excel and few other file formats if you have anything to be achieved with those data available to you. Okay, so this is about CBS file. Let's try to understand how to read a CBS file. Okay, there are certain types of already included file read write mechanism for CBS within Python. Okay, and we have a library called CBS, which normally it's a very small library, not big deal, but we use these things for our reading writing CBS files. Reading CBS using Python's inbuilt module called CBS CSV, comma separated files. Sorry, comma separated values, right? Using CBS reader object. The spreadsheet is very popular. And I'm getting comma separated values. Yeah, CSV, right? The spreadsheet is very popular and powerful application for manipulating data. Spreadsheets are there with computers since 1960s. We have started with typical flat file based separations, and then we used a number of tabular formats. This is how the actual database thought process or database got invented from a CBS file, because this was the first step of database we tried to achieve with a flat file. It populated means there are many companies that provide their own version of the spreadsheet. So you have tab separated values, you have comma separated values, you have hyphen separated values, and so on. So all these are normally counted as a separate CVS. Okay, it's a text format accessible to all apps. Each line, even if the blank, is a row. In each row, each value is separated from others by a comma, even if it's blank. Cannot capture complex things like formulas, or the special characters are not included in CPS. Okay, and here we have some program. I've shown it to you. We import CVS, we open the file. Oh, pardon me for this. We open the file, and I have not mentioned read write because by default it's get opened in a read format, and then I read that file in a CVS reader. This is a data set where I have a header. Header in the sense my first row will be the header of the CVS. That's a normal, notations we follow. Then we have rows. So there are all the rows next to the headers are basically my database, are basically my data. And I normally, get them dumped in a, this is a dictionary, right? Square brace. Come again, this is a dictionary or data frame. What is this? Could you recall? Anybody?
Can you repeat, please?
It's a list.
Yeah.
It's a list, right? Okay. So I'm, dumping those rows in a list with a loop, for loop, till the CVS reader counts end. Okay. CVS reader is basically my count. Okay. And then I got the rows and I return the overall rows list, and I can get it printed and all those things. Okay. I have a program I have already, did. I think I've showed it to you, so I'll not show it again. Let's not, waste any more time. I'll share this PPT with you so that you can go through them. I have a couple of good tutorials. We already had a look at it. If you want, I can play it again. Do you want to have a look at that CBS file reader video again? Or should we move on? It's simple enough, right? I'm just revising right now to showcase your solution. Do you want to play me to play the video?
No, I think so.
I understand it.
We understand.
Okay, no problem. With the above example of CSV file, I have created that appl.csv. I've already shared the zip file with you. You can open that program and try to read it. I have also included the CVS file, which I have targeted. So you can use that one, or you can use yours. CVS file. You can just create a CVS file in a typical notepad, like start run notepad. Okay. And then you can create a CVS file. First row should be the header. That's the row name of the columns. From second row onwards, you have the data, which whatever you want to include in that, right? Okay. Now here I'm specifying the R as an open file, as a CSV file, CSV readers. I take the CSV file in the CSV reader. Here first open the CSV file in the read mode. The object called CSV file, object name is CSV file. The object converted to CSV reader object, and here I'm adding the field with the for loop with CSV reader next and next and next, which is an iterable object, which I keeps iterating with the next method, so that I'll have each row into the list entity one by one. And then the columns are basically called fields. The field labels are taken from the first row itself. And that's a standard mechanism. Can I have the row 6 as a heading? You can, but that's not the normal practice. So if anybody wants to work on your project, he'll get confused. So normally, as a standardized mechanism, or as the oldest possible mechanism, I have my first row as a header. So there are some restrictions here. Of course, there are many advantages. That's why we use CSV file. CSV file gives us the best possible throughput available within the Python gambit, or be it C or R. And even if you're trying to use, if the data is not that critical, or you can basically encrypt with the cipher and all, then you have, you are, I think, covered in terms of security part. But as these are the typical plain text transfer, it can get compressed to the maximum level. So it's the execution will be the maximum execution will be with the maximum efficiency, and that's why we use CSV file. Okay, the rows I can append, so that whenever I add a new row, if I basically start updating that CSV file, I can append the row. So normally the last row, the last entered row is my last. So it works on LIFO, last in, last out type of mechanism. Okay, now we iterate through the remaining rows by using a for loop, so that you can have all these rows. You can count with line number type of methods available in CSV reader object. You can have a look at what are the methods available in CSV reader as well, so that you can make a really good CSV reader type of program and keep it ready for you. Okay, so let me play this video again. It's basically for CBS file, so that we'll get a hang of CBS reader, and basically we'll try to understand how we have achieved it last time. And come on. Okay, here. Okay. So okay, let's start with Python Pandas. Pandas is an open source BSD licensed Python library, providing high performance, easy to use data structures and data analysis tools for the Python programming language. Again, we're going to learn these things from Python, and overall, these are basically made to make use of the most efficient data transfer mechanism. And we're going to understand why, how, where this libraries is used, for which type of solutions, and we will try a couple of programs within Pandas as well. Okay, Python with Panda is used to a wide range of fields, including academic and commercial domains, including finance, economics, statistics, analytics. Well, about the history, in 2008, Wes McCann started developing Pandas when in need of high performance flexible tool for data analysis. It started with data analysis, typical analysis. Prior to Pandas, Python was majorly used for data mugging and data preparations. It had very little contribution towards data analysis. Using Pandas, we can accomplish 5 typical steps in processing and analysis of data, regardless of the origin. We can load the data, we can prepare the data, we can manipulate the data, we can model the data, and we can analyze the data. We'll see how we use these 5 steps to create our data scientific solutions with Pandas, when we are using Pandas, whenever we are developing a solution. Fast and efficient data frame object with the default and customized indexing. So we are predominantly use data frame objects here, which gives us the maximum throughput as far as the library and Python's mechanism for data usage goes. Tools for loading the data into memory, data objects from different file formats, data alignment and integrated handling of missing data as well, reshaping and pivoting the data sets, label-based data slicing, indexing, building subset of large data sets. As you can see, we are normally using mathematical terms, and henceforth we will be using mathematical terms, and that's how we get used to working or speaking for a given libraries. And that's also need of the hour. Whenever we discuss or we are trying to give interviews in Python data science, we have to use this mathematical term, label-based slicing. Label-based slicing. Slicing is basically, I am trying to disintegrate the data entity as a cell or a data set based on label, based on the categories, based on types. Indexing, I reindex the data depending or resort the data depending on particular category, particular column, particular data type. And I can be also building subsets of a large data set to make sure I use the data for my given project. This is done very, very efficiently. If you use something like C and your normal database, maybe Oracle, MySQL, big data, small data, and all those things, still the Pandas gives you a very efficient mechanism above all. And of course, Pandas are tuned to infrastructure as well. We'll come to that slowly. Columns from a data structures can be deleted or inserted. I'm talking about column. So altering the structures, as we are using data frames, you know how we can easily alter the data structures. Group by data for aggregations or transformations. Even it's also supported in data frame. Could you recall data frame data type in Python? We have done that thing long back, right? In might be, you know, our last life or something. Could you recall data frame? Who can recall data frame right now?
Yeah, I think you mentioned data frame in one of the slides, previous lectures.
Yes, we did data frame. We did some sort of, you know, data frame hands-on practice also. Let me even share those videos also, so you can have a look at it, and then you can do a practice on data frame also. In Python, in Pandas, we use data frame extensively, and that's the most efficient way of data throughput for a given solution understanding or data handling. High performance merging on joining of data, and time series functionality. We'll have a look at this time series functionality in a few slides. Just to give you a heads up, as we know, there's a variable commonly used called timestamp. Have you heard of this timestamp? Anybody?
No.
Okay. This is basically initiated with the
Date and
first.
time.
Come again? Yes, date and time. Date time 2 nanoseconds. Is first started with the database programming thought process, but every database have their different way of creating timestamp. And now normally timestamp gets added as an you know, traceability point to each and every row you add to the database. It's available in big data. It's programmed in big data. It's available in Oracle. It's available in Sybase. It's available in DB2. So these are hard coded in these databases to have a timestamp for each update type of functionality. But Oracle mentioned the timestamp differently, and now normally timestamp get created from the system variable. So if you're in India, your timestamp might be different from if you're in North America. We use British time format like DD, MMYY, and you know, so on and so forth. In North America, we use MMDDYY, right? So I normally say March 25th, 2020 in North America. In India, I normally say 25th March 2020. So this way, the timestamp is basically different in different regions. Just to ease on those things, there are some methods included in Pandas so that you can convert this time series plus various additional methods as well. Just to give you a heads up. So we are talking about a uniform programming practices across the globe, and that's where these Pandas also help us. Okay. Then how do you basically get the Panda? Anaconda has Panda inbuilt into it, as we discussed. So you don't have to do anything. If you update Anaconda, that's more than enough. If you don't, it'll still work. Don't worry about that thing. But yes, you have a pip installer if you're using Mac, or you know, if you're using any other OS than Windows, you might need to update your Pandas. Standard Python distribution doesn't come bundled with Pandas module. A lightweight alternative is to install NumPy using popular Python pip installer. NumPy and Panda are the most used library across all data scientists. In Windows Anaconda, it's a free Python distribution for SciPy stack. It's also available for Linux and Mac. So if you have Anaconda, Linux for Linux as well as Mac, the NumPy, Pandas, and SciPy are already updated. Don't worry about that. Panda deals with the following three data structures: series, data frame, and power. Data frame is the most efficiently and used data type with Pandas. These data structure are built on top of NumPy array, which means they are fast, they are efficient. Okay, does that make any sense, or I'm talking too much technical? Easy enough, right?
Yeah, good, sir.
Okay, no problem. Let's take a step further and we'll try to understand what type of different why we have mentioned these three data types again while discussing pandas. The best way to think this data structure is that the higher dimensional data structure is a container of its lower dimensional data structure. What does it mean? Container is basically a wrapper around your data. So whatever you want to use it effectively, you try to reduce the wrapper rate so that even the processing cycles won't get wasted. So here this wrapper helps us out to reduce all those extra processing layers for at a CPU mathematical execution layers. Okay, now a data frame is a container of a series, panel is a container of data frame. So this is kind of wrappers you have built it around the whole things to make sure the data transferred happened efficiently with the relevant methods and indexing allowed for optimum efficiency. The data structure series with single dimension, it's a one-dimensional homogeneous array, size mutable. So this is a kind of typical matrix format, right? Rows and columns, series. In data, it's just a row. When you talk about data frames, we have rows and rows and columns. So we have two-dimensional, generate 2D labeled size mutable tabular structure with potentially heterogeneously typed columns. Now I have specifically kept this slide because there were some questions in the interview. How do you differentiate series from data frames or panel? And these are the guys who extensively work on Pandas libraries for their mathematical crunching. That's why it's important to understand the difference between series, data frame, and panel. Panel is 3D labeled size mutable array, which is a kind of 3D database. In database, I have rows, columns, and then I have another additional descriptor. Might be, what do you want to call it? Rows, columns, and height. Or rows, column, and height. Yeah, we can call him height. So it's like a cube rather than a database. Database is a table, right? It's a tabular structure. So we have rows and columns. Series is just one row. So these type of data types, which we're going to use with Pandas extensively for data throughput at the maximum optimum efficiency. Does that make sense? Any confusion in series, data frame, and panel? Just remember it as an flat file, a database, and multi-dimensional database. But that's in layman's term. Whenever interviewer asks you have to tell him 1D labeled homogeneous array, size mutable, data frame, general 2D labeled size mutable tabular structure with potentially heterogeneous typed columns. This is basically a definition of a database in technicality. And then we have panel, generally 3D label size mutable array. Does that make sense? Any confusion at this moment?
No, we are good. Yeah.
Now we are going to use this thing extensively. So, we might need to revise this thing, before start of the class or before start of the session. Okay, let's understand the mutability again. All Pandas data structure have a mutable, can be changed except the series, and those are size mutable. Series is size immutable. It's mutable or immutable? Except series, all are size mutable. Series is immutable. Sorry, series immutable. All except series are mutable. Note, data frame is widely used and one of the most important data structure. Panel is used very little because it really complicates the matter to another level altogether. Series is a one-dimensional array, like a structure with homogeneous data. For example, following series is a collection of 10, 23, 56, and so on and so forth. There are certain formulas or there are certain preconditions to create this series. So you can have all those mathematical equations dumped into a series. and can be used in our data scientific solutions. Then we have a data frame. As it can be clearly see, it's a simple table, simple database. Data frame is two-dimensional array with a heterogeneous data. For example, this table represents a data of a sales team of an organization with a overall performance rating. The data represented in rows and columns. Each column represents an attribute. Each row represents a person. Each row is a record. Each column is an attribute or a category. Okay, as normally we understand in a database. Pandas Python import. So I import pandas. I create data sets, cars, passings, and then I normally use some variable to have this data set dumped into that, and then I just print that thing. Simple enough. Let me try to play this thing for you. And it's really one of the most efficient, program as far as retrieving and, retrieving, loading, indexing data set. Okay. So let me try to run this thing in Pandas. I believe I have already given this program to you, but not I'll give it again. Don't worry. So let me go to the practices. It's called Python Panda and data frame Panda. Okay, could you see this Maruti, Volvo, Tesla? Let me add a couple of more. So we have, Ford. I'll add another. Come on, man.
I think we are viewing your PPT.
Oh, sorry, I have not shared. Okay, pardon me for that. Oh, I don't know why I keep forgetting. Okay, I'm just adding, a couple of more types. So food and what I have. And then I'll add passing also. I don't know. So I have 12, 15. Okay. Now, as I've shown you, could you see this thing, or is is it like? Could you read these things?
Yeah, we are able to read it. Yeah.
I don't know what's happened to this guy. What is a comma? Yes, there was a comma. So, and I'll just run these things. So we can see it's really efficient. Well, with this small amount of data, it might not look much to you, but believe me, these are the most efficient, data retrieval mechanism. So they have relevant, data sets, data frames compared with each other, and this is how we basically get it retrieved. It's simple, hardly few lines of program rather than longer program for all those floras and faunas attached to it. So that's why we use Panda. Pandas is basically one of the most efficient libraries we've created within our Python Python programming things. Okay, then panel. Panel is a three-dimensional data structure with a heterogeneous data. It's hard to represent panel in a graphical representation, but a panel can be listed as a container of a data frame. So we have multiple data frames, and which are related to one and another. Okay, let me play a video for you for introduction to Pandas, and we'll take it up from there. Give me a minute. I have to go to this. Yes. Let me share this with you. So as we see how we basically build the series, the data frame, and series data frame and the multi-dimensional, what do you call
panel, right?
Panels, right? That's true. So these are the three we used in Pandas extensively. I'll share basically these slides as well, where you can try to create these series and try to work on these things, so that you can try on these things. And then next we'll learn NumPy, where we basically try to understand how we use NumPy and work around with actual solutions and try to build one simple solution, and then start learning from there. Okay. Any question for me as of now?
No,
No,
we are
I'm
good.
good.
Pardon me, I've took around few minutes more, 10-15 more today. But as we know, we have basically getting into the real hands-on data science work. So I would like to put some. I would like you to put some efforts and do practice on your own as well, so that if you have any challenge, there could be something which even I have not learned, but together we'll learn again and we'll try to understand it better. So don't think that I know each and everything in the world. There could be some shortcomings. There could be some things which are really came up new. There could be a library which is new, which I haven't worked on. So we might work on that as well. If you want to learn certain specific libraries, do let me know. I might take a day or two to understand it first, and then we'll discuss it together and we'll learn on that. Even whenever we join an organizations, there could be a couple of things which we might have not learned or understood throughout our session. So we might work on that then and there. So don't ever think like, training is just a ribbon cutting ceremony. No, we are together working for at least 6-7 months hereafter. So whatever we learn, whatever we are, do, we do it together. We learn together. We try to evolve together. Think it in that scenario. Even the additional videos which I, shared with you, please have a look at those so that you can have a good idea, or at least you can have a thought process of couple of mentors to understand how they think the solution is. And as we have said, data scientist is still not very disciplined community yet. We are still evolving. We are still building our knowledge. We are still building our solutions step by step. But the best thing among us is basically we share our thought process. We share our learning with others with some restricted licensing and all those things, but still there's a big amount of sharing within our scientific community, which really help us out to be the best data scientist at class. Okay. And we build on others' knowledge as well, rather than I keep learning in my island, in my home. No, we normally work together. We normally learn together. So whenever we basically be a data scientist, keep that motto, keep that, thought process in your, working as well, so that we get better day by day. We improve ourselves day by day. We learn new things day by day. Okay. Do you have any question for me at this moment? Could we wrap this session as of today?
Yeah, yes, sir. We can wrap. Thank you.
No problem. So let's meet on next week, and we'll try to learn some more, libraries, and try to do some really good data scientist, solutions. So we'll understand how to use these all learnings, how to implement machine learning, how to basically build certain valuable programs by ourselves. Okay, chalo then. Have a great weekend, and let's meet again on when are we meeting again? Let me. We are meeting on 28th, right? 28th, 9 p.m. 20th is Monday. 28th.
Correct, sir. Yeah.
Okay, sure. Thanks a lot for your time. Have a good
Thank you.
weekend.
Thank you. You too. Thank you.
Thank you. Yeah.